Alright, Jason, as promised, this is the first of two, possibly three videos that I promised we were going to send you for your reference, for your review, and hopefully for your approval. This is the first E2252 unit built per revision 03. This is the latest, and the only thing that probably Bruce is going to ask me to add is to add collars. Notice here we have some collars, and we'll fix that. The polarity of the 0 to 10, just the common, the positive. The collars used in the shunt feedback. And this is the unit we're bringing in 240. We don't show the fuse assembly or the fuse plate. I'll probably show that on the next video. And we're going to run really quick through it. Tony has taken the data. I'll probably email it to you in addition to these videos so that we can go over all this. We have the unit. Oh, the other thing is we want to show you that this is the terminal block that we ended up changing for the AC input, and the reason why the proposed one was not rated for the AC input for the 200 amps, 250 amps. So this one, it's rated for that. And what we have here is the AC input. The AC goes through the rectifier, and we are looking at the load. Notice we are not connecting to the freewheeling diode. Here's a 6100 board, and we're also, Tony is showing us the state of the enable status and the phase loss relays. We're also going to be looking at a couple of signals on the firing board. Tony's got the 0 to 10 volt SIG high command for open loop. It's got an output, and it's got the AC input. Let's go ahead and turn it on, Tony. So Tony turns it on with 120, which turns on the board, and it will turn on the fan, but right now it has that normally open switch. That's why the board has the 3 LEDs. It has a phase loss, so now when Tony clears that phase loss, we notice that now the relay for phase loss closes, and the enable status, it's closed, showing that the board is enabled. Can you inhibit the board, Tony? Sure. Okay, and now that it's enabled, it opens up. I have to check this with respect to the connection diagram. Tony pointed out that it's all okay. So now we've enabled. You're familiar with the boards. So at this point we have 240 volts AC. We basically have 0 output. And the other thing here we have is test point 5 on the phase board, the delay angle test point 3, and the DC output. So go ahead, Tony, and start increasing 0 to 10. So we can see there the output. You want to stop at 5? Okay, 5.2. It's got 101 volts. We see the delay angle roughly 81 degrees. Go ahead and bring it all the way up to 10. Alright, at this point we have 309. We have full conduction. The delay angle is 13 degrees, and again, we could induce phase loss enable status. The board is happy right now. One of the things what is the current that you're pulling, Tony? It said 18 amps. So if we were to monitor the 15 millivolts, that we're not going to do it on this video until we run more current. We'll show what happens when we pull, in fact, 250 amps, and we'll see how the shunt's there. So we're taking a look at the phase loss enable status, the 0 to 10. Alright, can you instant inhibit, Tony, while it's hot? There it is. The enable status changed state. Go ahead and bring it back. It did. It went back again. Now let's go ahead and do the soft, and we'll look at this. We can see the delay angle ramping down. Go ahead. Ramping up again. And this pretty much, and the RTD that will show the temperature, and that's something that we've tested. We can essentially show it at the end. Tony, did you have a chance to bypass the fan to verify that the fan is? Yeah. All right. So what we'll do with this video is we're going to send you the test data. We're going to send you this part of the circuit, and again, this is pulling out. You can inhibit now, 20 amps, 18.9 amps. What we're going to do in the next video is we're going to bring in low voltage and we're going to draw 250 amps to make sure that everything is buttoned up so that you can see your feedback and verify that the unit will handle the high current. On the very last video, we'll probably disconnect the units and we'll show you what the units look like. We'll bring up this concern with this terminal block, and once you and I review this information, this unit will be ready to go. The crowbars are built and they have been modified with relay as you approved it. We just have to implement our terminal block to give you the flexibility to change the threshold of the autonomous crowbar, and anticipate that we'll have those ready also early next week. This is the end of this first video.